So by the time you're at 80, it's this exponential curve. You're now developing a lot of senescent cells.
Dan, it's great to have you back here on the podcast.
Nick, I enjoyed our last show so much. I just hope we can think of more things to talk about when this one's done.
I'm sure we'll have a never-ending list of topics to discuss.
Yes.
Today, we're going to be focusing on stem cells specifically.
Yeah.
And when most people hear stem cells, if they know what they are, it's likely through the lens of clinics and injections. Tell me about stem cells and stem cell enhancement as a general topic, and then we'll go into specifics after that.
Yeah, that sounds great. So what are stem cells, first of all? So these are cells that are really vital to our health over a lifespan. They're a part of, we have 37 trillion cells, and those cells do not live your entire lifespan. And in fact, different tissues have cells that live for different lengths of time. So like a common and easy one would be red blood cells. And you can look at HbA1c, which is hemoglobin A1c, which is a good measurement of what your blood glucose regulation is for a window of time, which is 3 months, because that is how long they live, right? So that's just an example of how those types of cells that are in our body live only a certain amount of time. Other cells can live decades, even longer, like neurons. But in general, a lot of our tissues over the course of life need to be replaced once they die. And so in general, you have cells that can replicate. And in the process of replication, there's a little bit of renewal. And then eventually they reach what's called the Hayflick limit, which was something that was identified by Leonard Hayflick, published in 1961, where at that time we thought, okay, well, cells in a culture are immortal. They'll live forever. And he said, no, that is not true. They live 40 to 60 generations, if you will, and then they end up in something called replicative senescence. And then cells will die for other reasons. They'll go through something called programmed cell death or apoptosis. They can incur damage in other ways. But basically, we have the need to replace cells that are either killed or go to the end of their lifespan. And the stem cell system of the body replaces our own tissue. And they have two main characteristics. So they will replicate, and they will make daughter cells. One of them is like a clone of the stem cell. It can now undergo that same process of creating daughter cells. And one of them is also another stem cell that can turn into anything. The other cell of that daughter cell process is destined to become some type of specific tissue, right? It'll undergo a process of differentiation, differing into a neuron, an intestinal cell, a muscle cell, fat tissue, connective tissue of all sorts. So that is kind of an overview of what stem cells are doing in the body. And I think one of the reasons why it's been of interest to longevity purposes is that stem cell exhaustion is one of the original hallmarks of aging that was identified in that Cell paper from 2013, where they characterize these. A lot of people have misinterpreted them as like the causes of aging, but they're really reliable consequences of the aging process that you can look to and say, okay, this is happening when this entity, this organism is getting older, because it doesn't just happen in humans. It happens in other organisms as well. And so the bigger picture here is how, can we keep them healthier or modify stem cell exhaustion in a positive way that then extends health span. And going back to your original question, the way that most people conceive of stem cells is to actually get them injected into your body so that you can help solve some sort of specific issue, usually some sort of joint issue like pain in your low back or your knee or your ankle, and pain and discomfort. And that's how most people understand them. And we can, at least the therapy of stem cell. I'm happy to go into that further if you'd like.
Oh, we will.
Yeah, cool.
First, if we go back to what you were saying a minute ago, there's a couple things I want to dive into with you. And the first being that you mentioned that when a stem cell does its function, it turns into a like target tissue type. And then there's also a daughter cell, which sounds like that turns into another stem cell. So if each stem cell is also creating another stem cell, how do you ever run out of them or have like issues with your stem cell pool?
Yeah, they are some of the longest lived tissues of the body. They demonstrate a type of immortality, almost like Hydra or immortal jellyfish, which are organisms that don't really manifest aging as we know it. So just very quickly, aging is an evolutionary decision for certain species, most species, particularly species that undergo sexual reproduction. So two different organisms come together and then make a new generation. And Thomas Kirkland created something called the disposable soma theory of aging, which basically means what evolution cares about is extending the germ line, which is the line of tissue that is able to generate the next generation, not the soma or the body. The goal of evolution is not to keep you alive forever. It's to keep you alive long enough to reproduce. And then in our case, also to stay alive long enough to help the next generation as a grandparent, because we have very precocial development. So it takes a long time for us to, or judicial development, right? It takes a very long time for humans to fully maturate, and it needs a lot of resources and support. Compare that to, let's say, a loggerhead turtle, where they'll have like hundreds of babies hoping that only some survive, right? So the investment is rapid regeneration, lots and lots of babies, and then you hope some of them survive, even though many or most won't. That is another form of having the germline replicate. But in our case, we put a lot of investment into fewer offspring, and eventually we run out of time. That's the aging process for us is a period of decline from our physical peak, but not necessarily a decline in value. It's like evolution has prioritized alternative goals. So while you're no longer having the resources put into maintaining the peak physical form that has a purpose for survival and attracting mates, what it does care about is this aggregation of wisdom that you get over decades of lived experience that then can help with the younger generations in terms of helping them navigate the terrain of life, culture, tribe. And so we have a shifting of purpose as we get older. And we do need to maintain that physical body as much as we can, although it won't be the same emphasis of peaking out our physical capabilities. So that is probably a longer answer than you needed. But
yeah, you also mentioned rejuvenation, cellular rejuvenation.
Yeah.
How is that related to stem cells, if at all?
Yes. So let's say we didn't have stem cells. Then we would, when our cells died, we would have a ever decaying, out of the 37 trillion cells that comprise this, this organism that we call Dan, then, we would decade by decade have fewer and fewer of those cells. So the regeneration is replacing those, again, older tissues with new functional tissues so that we can actually make it across our organismal lifespan. There's a lot of different lifespans happening within the body by cell type, but overall they're contributing to the organismal lifespan that right now the average is around 80 years in certain developed countries, and like the top 30 countries all have an average lifespan that's within a couple of years. But then, of course, the maximal human lifespan is estimated to be 125 years, meaning that even under perfect conditions, we think that people will not live longer than that. And so the questions that are interesting for geroscience is twofold. Like, what are the factors that might be able to extend maximal human lifespan beyond these upper bound limits? But what's much more interesting is how do we improve health span so that we are thwarting the decay of the physical form deeper into the lifespan so that we actually have more youthful function in our 70s, 80s, maybe even 90s and 100s, if we actually are able to target things that are driving the senescence. And we think of senescence as like cellular senescence, but organismal senescence is really the decay and function that our body is able to display.
Interesting. So you have the stem cells, and then over time, those stem cells eventually start to lose some of their potency. And so then you have the like senescent stem cells. And is that the reason? Otherwise, it seems like if the stem cells are replacing themselves one to one, you would never have to worry about this because it would just be, the stem cells would just be replicating enough that you have the same pool as when you were born.
Yeah, so it's a little bit different. So once a cell differentiates into its tissue type, it can undergo replication, right? It can undergo now it is let's say a full mesial cell. It can replicate, and then it will eventually get to a place where it'll undergo cell death, programmed cell death, apoptosis. That's most cells by far. But if it gets all the way to the end of life and like its replication possibility, and it can then go replicative senescence, it will become senescent. And then that is like a whole different type of, we call them zombie cells. And the reason we call them that is because they're partially alive and partially dead. They're releasing a lot of inflammatory molecules into their surrounding that have some functional purpose of helping with wound healing, but also to trigger as a beacon to tell the immune system, hey, come clear me out. And the problem with an increasing burden of senescent cells is that your immune system is less effective as we get older. We undergo thymic involution. Our thymus gland is where we produce our adaptive immunity. So B cells, T cells, and as that over time degrades, then our immune system becomes less potent at being able to do immune system jobs, fighting infection, but also handling internal cleanup. That's another thing that it does. And so as a result, you now have over decades, like when you're young, you're making senescent cells and you're clearing them. So the net burden is basically zero. By the time you get into your 30s, you now start to see an increase in the amount of senescent cells that are occurring because there's more damage, and damage ultimately is what drives the senescent mechanisms within a cell, right? Like a cell does not want to stay alive when it's sick, right? And that's why we have these built-in programs that help it die, and in this case, become a zombie. The other part of the analogy of the zombie is not that, because when they get into this senescent state, they're releasing a lot of inflammatory molecules, so they're not contributing to the function of tissue. So that's why they're like partially alive, partially dead. They're also inducing what's called bystander senescence. So because of the inflammatory cascade leaving those cells, the tissue degrading enzymes that leave these senescent cells, there's a lot of them. It's also causing their neighboring cells to become senescent. How does this relate to stem cells? Well, one of the reasons, we don't actually lose a lot of stem cells as we age. They just don't. Stem cell exhaustion, actually, I mean, we do lose some, but stem cell exhaustion is because the inflammatory burden in the body rises and the stem cells can't hear their signals to actually undergo the healthy stem cell cycle of leaving their niche and then becoming different target tissues. That's what's going on. And in fact, Irina Conboy at Berkeley has shown, if you, through like what are called parabiosis studies, where they sew an old mouse to a young mouse, which is very gory, and what they find is that that process makes the younger mouse older, but the older mouse younger. And because there's an exchange of these fluids, and so there's almost like a clearing out of the inflammation. And as a result, all of a sudden, the older mouse starts to regenerate tissue at what would be considered a younger level, like at the same rate that they were when they were younger. So that's why our stem cells don't perform well with age. They can. They retain the capacity. We have to try to shift the internal environment so that they have a better chance of doing their job.
Yeah. Okay. So it really does seem like that inflammation is the root of a lot of disease. And then if you were to, I guess, do routine blood work and to measure inflammation levels, a bunch of different ways of doing it, if you saw high inflammation there, would that indicate that you might be a good candidate to help or use therapies to remove or reduce the burden of those senescent zombie cells?
It's challenging because it is a very dynamic situation. You're going to be generating inflammation in response to pathogens, in response to hard workouts, in response to poor sleep. So there's a lot of acute variables that are going to cause an acute phase response or just a temporary transient elevation in immune molecules. Over time, however, if you measure regularly, like I could imagine in the future, let's say there was some sort of implantable device or almost like a CGM that was measuring more things than blood glucose. Could you actually see what your actual, day by day variable for various inflammation markers is to kind of get rid of the noise? Kind of think of it like BMI measurement with a bioimpedance scale. Like any one day might not be super accurate, but if you measure for a month, you get a pretty good, like day by day, you get a pretty good average that's accurate. It would be like that. But that's a little bit of, sort of future pontification. Like what might this look like in the future? It's not here now. But yeah, generally you can see if you have, let's say, high levels of C-reactive protein or tumor necrosis factor, IL-6, other cytokines regularly, then you might be dealing with either either whatever is driving it, you're dealing with a higher level of inflammation, and that is going to accelerate. In fact, a lot of our biological age measurements are very sensitive to inflammation. So when we see like a reversal of biological age, what we're really seeing is a lower level of inflammation and how those epigenetic marks reflect that. But that's another subject.
Yeah. In those cases where you see inflammation that's a bit higher, obviously that's going to be a good target to engage in, to work on before you start using the stem cell therapies and other forms of like rejuvenative medicines. But like if you had, say, high levels of that inflammation and you did have an underlying like subclinical infection, or say it was even because you were exercising very hard and not recovering enough, you were under recovered, is it possible that using one of those therapies could actually backfire and make the situation worse? Like if you had that infection, your body's mounting this inflammatory response as a mechanism to like stimulate healing, and then you're stripping that inflammation away.
Inflammation has an important role in the body. It's kind of, we're so quick to label things as like bad or good, when the badness of it is when it is out of balance. And so if you think of inflammation as another mechanism through which the body communicates messages that are important, think of a rising of low-grade chronic inflammation similar to a person who has lost acuity in hearing. So now what the body needs to do is, what you need to do is raise your voice in order to get the same message across to the hard of hearing. The body is raising inflammation in order to maintain the signaling of what inflammation is typically doing, right? But as a result, living in that state, it's a reaction from the body to try to do something good. But as a result, it does interfere, creates a lot more static on the line, if you will. So all of this intercellular, intracellular, intercellular, tissue communication, organismal communication, all the ways that this is communicated locally and systemically, it has a harder time doing its job and hearing the signals. So to answer your question, yeah, sometimes suppressing inflammation, like right after an injury, you are not allowing for the immune system to do its job, which is to clear debris. You want that, right? Because for a lot of damaged tissue, the body does not try to fix it. It clears it and replaces it. And so you want to allow that process to happen. I don't necessarily think, although maybe there are some situations, but like, let's say you do have like higher levels of inflammation just through aging, right? The normal aging process. Like part of the way that our product does work is to try to lower that inflammation temporarily to give.
Which product is this? The stem cell?
This is our
formula?
new stem cell product. But that's one of the targets of the 15 different ingredients that we have, that is actually trying to limit the inflammation temporarily so that you do facilitate short-term augmentation of the regeneration process.
Gotcha.
Yeah.
What would you say are the most promising, like non-invasive ways of improving the body's like stem cell pool, utilization, activation, whatever you want to call it, the ability to get therapeutic benefits out of the stem cells?
Yeah. So actually, I think to answer this really well, it would make sense to talk about what like the normal life cycle of a stem cell is, because then that'll help create a framework for people to understand like the different areas in which you could possibly intervene or try to. So if you think about a stem cell, you mentioned the word potency. So I'll get back to that, but we have these stem cell pools in the body. And you can have intestinal stem cells, mesenchymal stem cells, hematopoietic, neural stem cells. There's all different types of stem cells that are in the body designed to replace tissues in that area, or sometimes even systemically. Like, for example, hematopoietic stem cells are in bone marrow and they leave the bone marrow and then will circulate, and then they differentiate into different types of blood cells. So let me talk about that. So they reside in their niche, and most of the time stem cells need to be sleeping. They're in this quiescent state. That's actually really important for them. In fact, if you increase the demand for regeneration dramatically, or you have a product that is trying to pump out stem cells all the time, oddly enough, you will create stem cell exhaustion faster because you're overworking that system. So you want to let them stay in their quiescent state for, that's an important part of stem cell health. When a stem cell is then activated, it'll undergo this really interesting process, which tends to be predominate at night, right? That's when we do a lot of regeneration. And so what happens is these stem cells receive certain chemicals or signals, I should say, that will loosen them from their niche. And again, think of a stem cell in bed. It's like a little kid. It's in bed. His mom comes and wakes it up. It says, okay, time to get up and do your job. And it'll wake it up. And then that is called activation. And then once it gets up, it'll usually undergo some sort of proliferation process. And this is where the stem cell is making daughter cells, right? And then some of those stem cells will stay right there in the niche and just go back to sleep. The other ones then will leave the niche and they'll undergo a mobilization process to start circulating. And there's this beautiful sort of dance of chemicals where the receptors that are expressed on stem cells like CXCR4 are looking for these homing beacons, which are like it's a receptor. Think of it like a nose on a cell that's trying to sniff out where the cookies on the shelf are, right? It can smell them and it's got to go find them because they're not wandering aimlessly. They need to find the cookies. And so once they're in circulation, then there's these other molecules like immune molecules like L-selectin that kind of help them find where they need to go. So they don't just drive past the exit. They like start to adhere to the vessels proximal to the site of injury. And then they will get into the tissue, and at which point they will start to undergo the differentiation process. And what they're doing is they are looking at, they have receptors on their cells, and they are looking for cytokines, signals from the extracellular matrix, things like that activate these ancient cellular pathways. These have names like funny names: sonic hedgehog, hippo, Wnt, beta-catenin. There's only 7 or 10 of them. And then there are multiple subclasses of those, but these are 1.2 to 700 million years old. And so what's important to know is like when humans evolved onto Earth, it depends on like which version of Homo you want to say, but like 2.8 years ago, 2.8 million years ago, it's not like we reinvented the wheel. We were building on top of a lot of the development, the biological development that had happened previously, right? We didn't start to generate our own cells. Our cells are very similar to cells of other organisms that have the same eukaryotic frame. And so anyhow, these signaling pathways that are very old, they will then bind to the surface receptors of these stem cells, and that will initiate this intercellular cascade, which ultimately results in the activation of certain transcription factors, which play a very important role. A transcription factor is like a message that goes to the genome and say, okay, let's make these proteins, but not these. Okay? Because we have...
And why would you want to do that? Why would you want to make certain proteins?
Well, because all of our cells have all of our genes, but you don't want to be making all of the proteins that each of those genes can make all the time. You want them to make very specific proteins that then create a very specific kind of cell, right? You want it to make a muscle cell and nothing else. And so those transcription factors that are activated by those ancient pathways that then give it a very specific signal, and it starts to differentiate. It starts to turn through multiple stages, a progenitor cell into ultimately its final form, locking in what we call cell fate. And the dance that happens is beautiful. The transcription factors not only are, like I said, turning on the right proteins, but they're simultaneously turning off, like preventing the wrong ones from being made. And as it takes that step down that process, it's almost like a ratchet. It only goes one direction. And then it starts to, the cell fate starts to get locked in through changes to the epigenetics of that particular cell so that it becomes, like I said, something very specific. You do not want stem cells that left their niche and arrived in a muscle to make a neuron or an endothelial cell. It won't be functional in that space. You want it to make a muscle cell. And so that process is happening throughout the body. And it and think of it like a lump of clay. Right? It can become, and to go back to this idea of potency, this is a little bit more technical, but basically potency determines what type of tissues that type of cell can become. So a totipotent or pluripotent stem cell can become just about anything in the body. It can become anything. So like an embryonic stem cell can literally turn into any sort of cell type that you need.
And that's why those are considered to be the most valuable types of stem cells.
That's right.
Or potency of stem cells.
That's right. That they're most prized for that reason.
Yeah.
They also suffer from less immunologic restriction. So, if you can use them from a donor versus yourself, and you will have an easier time having those implant and be successful with that without creating an autoimmune issue.
Is there any drawback to them?
Of the pluripotent stem cells?
Yeah.
So the research field is pretty interesting in that what we're trying to do now, overall, I would say goals are to take any type of tissue, even any type of cell, like even just a surface skin cell, and reverse it into becoming a pluripotent stem cell that then could become anything. So it would be your cell. You could take a hair or buccal swab or skin. Pretty fascinating. And that was the idea that could even be possible was first identified by Shinya Yamanaka, who now we call them Yamanaka factors. These are transcription factors. There are 4 of them. And if you put them in a Petri dish with some differentiated cells, like cells that have become something specific, they can be reverted back to a place where they can now be molded into something different and new. So a good analogy is like when we're thinking about clay, right? When it's wet and malleable, you can make it into a bowl, you can make it into a plate, you can make it into a cup. Once it hardens, you can't reshape it into something. It's like its fate has been determined. It's going to be that, or it's going to be broken. Now imagine that what these Yamanaka factors would do to the clay, if we're going to stick with that analogy, is like you could take a hardened plate and reverse it back into a lump of clay that now could be made into a cup or a bowl.
When I looked at the Yamanaka factors a while back, I love the idea of it, but the actual factors, the chemicals themselves, it's not like they're vitamin C and like things that are like totally safe and very therapeutic. They seem to be like more experimental chemicals.
You know what's funny about them? Like the amount of stem cell, the amount of progenitor cells or pluripotent stem cells that were generated from that experiment was like less than 0.01%. It was a tiny amount, but it demonstrated the possibility. And so what very sophisticated, research is now trying to do is to try to manipulate the understanding that this is possible and to then, get to a place where it's ultimately commercialized. And like a good example of that is Altos Labs. Have you heard of them? Yeah, they're this company that's dedicated to reprogramming and regeneration. And that reprogramming is basically what we're talking about here. You're now, it's like if you took a program and you made it into a certain software package, you're going to like dial that back and make it into something different. And so they're really focused on harnessing the ability to possibly reprogram and restore health and resilience. And so there is an idea, there's some models that have shown that you could like imagine this, like you've aged to age 60 and then you undergo this reprogramming and it's like you're 40 years old again. The problem with that is that you certainly can generate cancer in that process because that, again, a cell needs to listen to the way that all of this is orchestrated in the body is so complex. And so if some of those cells end up being differentiated into like, you dial them back, but some of them lose their identity and their developmental path, then they don't know what they are. And that gives rise to the possibility of generating cancer. It's a problem that needs to be solved by these companies that are looking to manipulate our physiology in a way to do something that is very unnatural, but also not evolutionarily novel. Like we do see axolotls and other types of salamanders and other creatures, they do this and they're being studied in the process. Like, for example, if a salamander loses its hand, like an axolotl loses its hand, it'll create this bud first around where it lost its limb, and it'll start to undergo this de-differentiation process for those cells in that area. So they're dialing them back to this, like, it's like taking the plate and making it clay again. And then it's back onto its developmental path and makes the exact tissue type that it needs for the bone to form into the exact digit shape, the skin. I mean, it's amazing that it can do that. An axolotl can even have part of its central nervous system destroyed and it can regenerate it.
Whoa.
Yeah. Yeah. So we see this stuff in nature. And so what Altos Labs, what's so interesting about them is in 2022, they raised $3 billion in their first round of funding. From people like Jeff Bezos and others. And then they brought in these pioneers. They brought in Shinya Yamanaka, right? They brought in Juan Carlos Espizota Belmonte. These are people that have made enormous contributions research-wise to understanding how all this works. And they're now dedicated to see, can we come up with some sort of reprogramming, rejuvenation package that will actually enable people to maybe dial back their age or even preserve it? What if the net result of that was not making you younger, but making you age 3 months out of every year? Like maybe they could do that. And it'll always be a combination. Well, what you'll find, right, when we go back to the hallmarks of aging, there were 7 of them at first. They came out with 3 more 10 years later, and there'll be more certainly that are identified. But what that means is that it's very unlikely we're going to have one pill that's going to solve everything. Polypharmacy is going to be the goal, probably the likelihood of the future, where you actually have some of these processes temporarily separated. So you're doing one thing first, and then you wait, and then you do another thing, and you're like on this protocol that overall is keeping you healthier longer. But it will undoubtedly be multiple different targeted therapies that are doing different things. So that's the future.
Yeah. Well, to step back from the future into the present a little bit, if you were to like stack rank, like how do you go about implementing this into your routine? Like I'm just imagining, first of all, as you already mentioned, reducing unnecessary inflammation. So if there's a bad diet, if there's excess alcohol consumption, stuff like that, these things are going to be adding burden to the body. So a good place to start is to reduce that, the basic tenets of healthy living, essentially. But then it's also like avoiding damage in the first place. So beyond that kind of thing, like even just injuries that occur via sports or from daily living, those things are going to put more burden on the body to use stem cells to replace the damaged tissues. So starting with those seems like a good place to begin. And then after that, what is the next link in the hierarchy of importance?
Okay, so this is such an important point. essentially when we are living out of sync with the biological expectations of our body for the environment that was shaped by evolution over many years, right? A long time. As we introduce novelty into our pattern of living that we describe as modern living in all sorts of forms, environmental toxicity, diets that don't offer an adequate amount of micronutrients and have altered macronutrient profiles and low amounts of phytonutrients, all of those things, plus poor sleep, lack of physical activity. It, I'm sometimes surprised that we do as well as we do, given how we live, but all of those serve as another independent contributor to accelerate biological aging because we generate more proximally, like an increase in chronic inflammation when we're not eating right, when we're not, right, sleeping right, moving right, getting the right sun exposure, getting too much sun exposure. All of those things will cause an acceleration of how fast we age. And so what that does is it's going to make the inflammatory burden higher by age. And that is then going to shut down other processes for regeneration. And so, yeah, you're just aging quicker. And so it really cannot be microbiome, right? Like, obviously, the gut microbiome is enormously important for our health. And if we're, eating in a way that's not taking care of our enterocytes, or the cellular lining for the single cell lining that lines our intestinal system, then you're going to allow more molecules to get through into the body, which then can drive inflammation. That's another factor. And I know it can feel like overwhelming, but the fact of the matter, all these things do contribute significantly. And you always want to be trying to do as good as you can. So keep learning, keep trying, and do your best. And like I said, it can be overwhelming, but don't let that feeling get in the way of the fact that when you listen to shows like Nick's and you learn something valuable, you can make meaningful changes in your life that you now have the opportunity to exploit for the rest of your life, right? You learn more about sleep, and now all of a sudden you're sleeping better. Or you're engaging in the factors that help this natural sleep processes occur better, which leads to feeling better sleep, more restored. All of those things matter, and we have a lifetime to benefit from learned knowledge, which to me is exciting. It's like, wow, what am I going to learn tomorrow? And I learn new stuff all the time. It'll always feel overwhelming. It'll always feel like, maybe a little frustrating. Let it feel exciting. Like there's just more opportunities to take care of yourself better. And so, kudos to the people that are listening now. Like you're ahead of the game.
If we go on to well, first of all, I think the foundational nutrients, if you have replete levels of those, you're going to do better when it comes to stem cells. I'm not even sure through the mechanisms, but they tend to make everything in the body work more effectively. So especially the vitamins and minerals, you mentioned phytonutrients, of course, those across the spectrum, it seems like those are a really good place to start because they're also a lot easier of fixes to implement, whether it's adding supplementation or just choosing a little higher quality foods. After handling the very basics like that, are there any fascinating molecules or ingredients that you think have a lot of promise in helping the body's stem cells either work more effectively or increase in number?
Yeah. So, aside from doing all the things that we know to be healthy, both the foundational things like diet, exercise, sleep, and now the new techniques that are exciting in the last couple of years. So think of things like sauna, cold exposure, red and infrared light, or photobiomodulation, hyperbaric oxygen, things that have a little more technical sophistication to them that are adding another layer of value. All of those things that I just mentioned also will contribute independently to your stem cells in various and interesting ways. Supplements are another thing that certainly can contribute here. And I think the broader argument is that even if we're eating a really good diet, we tend to eat a there's a relatively low diversity of our diet. So what do we eat if we're eating a plant-rich diet? We're eating cucumbers and carrots and celery and leaves and tomatoes and eggplants, right? It's a limited set. But there are 80,000 edible plants that are in nature, and hunter-gatherer estimates would show that they could take in 700 different plant types in a year. And on average, at least in one sample, 20 to 30 different types in a day. And then those would change seasonally. And I think what confounds the conversation is that they're not essential like micronutrients, like minerals, like those that we consider them essential if our body, we need to eat them in order to get them. Where I think what ends up happening is that there is this huge pharmacopoeia in plants, mostly that have some redundancy. Like you might see one compound have an effect, and then it's partially will be supported in the same way, like the effect will be partially supported by another compound. And so it's almost like it's the overall benefit from these is spread across the masses, and it makes it harder to pin down essentiality. It doesn't mean that it's not important. In fact, if you look at a very low phytonutrient diet compared to one that is, relatively high, you see like a 20-year lifespan difference.
Wow.
It's big. It's big.
Yeah.
So the question now and the fun part is one of the reasons I wanted to work in the supplemental space is because I think the bigger picture, that sounds kind of boring, but you're adding diversity to the amount of plant compounds that you're exposed to. And the way that the supplement business works is that you find ones that have a particular, they have research on a particular goal, like cognitive like things that might improve various domains of cognition. Or in this case, or like another product that we make, things that might target senescent cells and cause those senescent cells to die. If our immune system isn't clearing them, we know that plant like flavonoids and other types of molecules can actually clear those senescent cells. That's cool. And in this case, we ended up creating a stem cell product, and it's quite different than how you typically think of medical stem cell therapy. So real quickly, like the typical way to think about that is you get your own stem cells extracted from your body. Typically, what we work with is hematopoietic stem cells. So they will be extracted right at the iliac crest, which is an area that is close to the surface, a bone area close to the surface. You aspirate through this little surgery. You do a little bone biopsy. So you'll take out the stem cells, concentrate them, and then you'll inject them back into an area of need. And that is most typically how the medical stem cell therapy works. Although there's been now some thinking about just injecting them IV, which I think is very interesting and promising, but we definitely need more work there. So it scares me actually that people are going to be doing this before they should, which is already happening, right? We're going to over-focus on the potential benefits, but not on the risks. And new therapies can hide in the gray zone when we don't know all of the effects, so we can focus on the benefits without fully understanding the risks. And that's a tension that we have to face, right? But real quick, there was recently a Senate bill, Senate Bill 1768. It passed July of this year, and it's a new law that allows licensed physicians, so MDs and DOs, to offer certain stem cell treatments that are not approved by the FDA, but they can only use them. There's restriction. They can only use them in orthopedics, wound care, pain management, and the cells have to come from an FDA registered facility. So which means they must meet really strict standards, and the patients also must be given informed consent, so that they're sort of acknowledging like, all right, I'm taking some risk here. And then, very clear disclaimers about what's known and what's not known. But it's exciting, and it's happening in Florida. And what it's going to happen is it's going to make Florida a destination for medical tourism in the United States. So what was happening previously is people were going down to Costa Rica or Mexico, and they were getting their stem cell therapies that, by leaving the country that had looser restrictions. Now, at least for certain things, you can actually go to Florida and get some of those therapies. And for whatever reasons, Florida has really been like a hub for stem cell. They've been pushing the boundaries for a long time.
If we take that, we compare and contrast getting the medical procedures versus using things that support the body's own stem cell activity. Obviously, there's going to be a big difference in cost, like cleanliness and sterility of like the medical product that you get, different types, different administrations, lots of different things there. Like, what would you say if someone is like deciding between the two, how to go about choosing one or the other?
So I'm so glad you asked that question, because if I were to get stem cell treatment, and I'm considering it because I have some damaged Achilles which actually, I'm going to take a second and explain that. I injured my ankles playing basketball in my 20s and even in high school. So it was like a 10-year process of like, once you stretch a ligament, you're just much more likely to continue to turn it over each time, causing a lot of inflammation and swelling. Well, 20, 30 years later, I'm now 51, and that has led to this chronic inflammation. I've sort of burned, now it's always an issue. And because I had that damage early in my life, it led to me tearing both Achilles partially, and I also now hobble around, right? So that part of my body is older than other parts of my body. So I might get some stem cell therapy. If anyone were to get stem cell therapy medically, I would 100% consider taking our product, because our product is all about promoting stem cell health. So if you're going to be spending thousands of dollars to get an expensive medical therapy, which, by the way, my orthopedist, I really like him. He's like, yeah, it's really effective. He's like, yeah, it's $4,000 an ankle. I mean, it's expensive, and you might spend more elsewhere too. But he's like, you're going to have some serious relief for like 3 to 5 years. So it's also not permanent. But if it can get you back into doing healthy things, maybe you would have even a longer period of benefit. But during that time, so the way that I would do it is I would take our stem cell product on the day that I would start day one, because it's a 4-day product, kind of like, our senolytic product. You take it 2 days, then you wait a month, you do it again. This is similar to that in that you do it for 4 days in a row, and then you wait another month. And what it's doing is there's 15 different ingredients, and all of those ingredients are really targeting the activation and proliferation process, the mobilization migration process, the differentiation and protection process. So it's trying to support stem cell health at all the different parts of it's doing its job, right? And so I take it at night, because again, that's when a lot of our regeneration occurs. And if you think about it, like growth hormone stimulates the release of stem cells. Melatonin is an antioxidant. It helps to lower the inflammation burden, the oxidation burden, because oxidation and inflammation sort of work hand in hand. And then it also, you have lower sympathetic tone, and you're parasympathetic dominant. All of those conditions, the internal conditions, are in favor of regeneration. And so taking this product at night is going to then fuel, theoretically, it's going to be helping to support that process even further. And I'll give you an example. So like one of the products that we have is called a Fannin Plus. And what you see with that product, it's the form of like blue-green algae out of the Klamath Lake, which is it's kind of has a cool backstory. But what it's doing.
Product or ingredient?
Oh, did I say product? I meant ingredient in the formulation.
Gotcha.
Yeah,
okay.
Yeah. But what it's doing a couple of things. You will see a 25% increase in stem cells above the regular baseline within an hour of taking it. So it's a modest but meaningful increase in stem cells. That's one example. Sea buckthorn is another one, another ingredient in the formulation. It is doing something very similar. It is helping to mobilize, activate, and then proliferate, but only certain stem cell types. Where a Fannin Plus, which is this blue-green algae, does it to all the stem cells in the body. The sea buckthorn is very rich in polyphenols, and what you see is that certain cell lines, like intestinal stem cells, mesenchymal stem cells, another pool for connective tissue, certain tissues are activated. And the way that it works is that mostly through like an increase in nitric oxide for that particular ingredient. It's increasing nitric oxide, which is important for releasing them. And then it's also helping to lower the inflammatory burden through the antioxidant effects of that compound. It's really hard to kind of get an understanding of the elephant by talking about all the ingredients, because then it just end up being like, I don't understand. But I wanted to highlight like example of 2, and we could talk about other ones if you want. But the overall goal then is to just help the process. And the way that I think of it, if you're getting older and you go back to the hearing analogy, right? We are temporarily in a way raising our voice to signal to these stem cells like, okay, do your job, and helping them over a 4-day period do their work. And again, we wouldn't want to be stimulating them constantly. That could drive exhaustion, right? Stem cell exhaustion. But doing it 4 days does make sense. And the way that I do it, which I think makes even, I really think these products could be considered one in a way, is I do the senolytic product for 2 days in a row on the first weekend of every month. And during that time, I do low protein dinner the night before, fast in the morning when I take it, do like 15, 20 minutes of high intensity training. All of those things are shaping the internal conditions to let the supplement, high doses of flavonoids and other phytonutrients, kill off those senescent cells. You probably will see an increase in inflammation for a few days because you're killing those cells. And then starting on Wednesday.
Why low protein diet in conjunction with that?
Yeah, because protein we know stimulates mTOR, mechanistic target of rapamycin, and mTOR is really going to help make those senescent cells more resilient, right? We don't want to give them a lifeline when we're trying to get rid of them.
So if you're going to do an extended fast or something where you're going to keep mTOR lower and AMPK higher, would that be a good time to take the senolytic as well?
Ultimately, I think for like the healthspan model, the idea is that you're going to take it 12 times in a year, the senolytic, and you're going to take the stem cell for 12 times in a year, once a month. One is 2 days, one is 4 days. And so it's hard to time everything, right? But that's why I just put it in my calendar. I've been doing a senolytic protocol since 2017, where I just invited friends to a calendar invite, and I was doing high dose Fisetin. According to James Kirkland's protocol that he did at the Mayo Clinic that showed improvements in vascular health and joint pain. And so really cool stuff. Actually, he recently joined Cedars-Sinai and is starting a longevity lab where they're going to start to test really novel, cool combinations. Because like I said, ultimately the future is combination therapy. And but yeah, so then I do that, wait a couple of days, let the inflammation die down. Then you take stem cells. And in that period, I'm eating well, like I'm not trying to fast. I'm eating a lot of protein, right? You're fueling regeneration. And I'm doing a lot of more zone 2, right? I'm not trying to create more damage because I'm trying to build. So I'm doing like a lot of blood flow. I'm doing hill climbing. I'm doing rucksacking. I'm doing walking. I'm doing some light jogging. I'm not doing like super heavy weight training. So that's.
I'm glad you brought that up. I was going to mention that very thing. 2 of those things, actually. I think those are important to underscore. First of all, like if you're doing any kind of stem cell procedure, to follow that basic template of where you're really letting the body clear out senescent cells to begin with via the lifestyle you mentioned, the low protein, in conjunction with fasting and some light movement, but then also not putting your body under intense strain, such as with like really heavy weight training when you're using the stem cells, because your body is trying to rebuild and repair. And whether you're doing the supplements or you're using the medical stem cells, you can take a couple days off of like the heavy lifting so that the stem cells get used in areas that are more important like to the overall regeneration of the body versus just helping the muscles repair faster.
sometimes we want to do all the things all the time, and sequencing them and having the right, like, how do we, if we're going to invest our resources in doing this stuff, how do we do it right? How do we get the most out of it? So the other thing too, I don't take NAD, Qualia NAD, which is, a product I love because we talked about it last time. I don't take that during the senolytic. That's another thing that's going to actually help give a lifeline to these cells that we want to clear. But then Greg on our team, who's the head of product, he actually does double the dose of NAD during his stem cell window.
Oh, stem cell. Okay.
Yeah, I've not done that one yet. So don't give them the lifeline. Don't make your cells healthier and more resilient during clearing out senescent cells, but then do support that processes for now causing the regeneration. So if you kind of were thinking more outcome based, with the senolytic, you're lowering inflammation because you're reducing some factors that are driving it. And then that is the perfect place to now drive regeneration. And I'll mention this, like when you're young, you're making stem cells, but you're making senescent cells, but your body's clearing them out. So you really don't have an increase in senescent cell burden until you are maybe in your 30s, depending on how you live, right? At that point, you start to see a decade by decade increase, more than a doubling, right? So by the time you're at 80, it's this exponential curve. You're now developing a lot of senescent cells. And the amount of senescent cells in your body is not that much. Like it's 0.01% of your cells become senescent. But 1 in 10,000, like if you have one of your cells, 1 in 10,000 cells become senescent, it has an outsized effect on affecting your body. So they are a problem. We do want to get rid of them.
Yeah. I'm also glad you brought up Dr. Greg, because I was talking to him at the biohacking conference a couple months back. We were talking about stem cells, and we were talking about the Qualia approach to stem cells. And to me, it makes a lot more sense because of what we're talking about. It's stem cell exhaustion, literally being one of the hallmarks of aging. So if we know that they should be quiet or dormant most of the time, and then you have waves of increased activity, why would you want to constantly be stimulating their release and depleting the pool? It just didn't make sense to me.
That's right. And so there are products out there that it's like, every month, every day, you're just, trying to bombard them. And you might, in the spirit of doing something good, you might actually be causing your body to age faster, right? You're making a trade-off where you're driving excessive regeneration and ultimately causing stem cell exhaustions quicker.
I think in general, like there's a lot of overwhelm when it comes to supplementation too, especially it's like, okay, I gotta take these things every single day for the rest of my life. So the whole strategy that you guys are using with the senolytic product, and then also with stem cells of just taking it either 2 or 4 days per month, is a breath of fresh air.
I agree. And it's one of the reasons I mentioned, just put it in your calendar. Like I know, as much as I like this stuff, study it, value it, if it wasn't in my calendar, I would have missed a lot of days where I would have, like, months.
For the other things that people could either stack into their protocol before they run the stem cell or after, are there things that you think would have or theoretically have a good effect? I don't know if there's any stem cell, or I guess perhaps copper peptide would be like one of the few peptides that might have a beneficial effect on stem cells. And I'm not sure when the use would be. I know there's interest in certain therapies like clothotherapy for genes. What about like mitochondria support? I mean, obviously NAD is going to help with mitochondria, but like, what would you say if someone's advanced in this realm, they want to explore deeper things they could look into or consider?
Yeah, I think about this question a lot. And what the questions that you just asked is really like a field of research for the next decade and beyond. So we're going to be trying to identify what are the protocols for optimizing around efficacy for these, with like the field of senotherapeutics. under which senolytics lie, right? The whole idea of trying to manipulate senescent cells is a field. You have xenomorphics. These are compounds that don't actually kill the senescent cells, but they make their inflammatory profile. They make them like less harmful, basically. You have xenoantigens. Some researchers are looking into that. So can you find some sort of cell marker specific to senescent cells, or use drugs that would help those cells specifically express a target for a vaccine designed specifically to kill or clear senescent cells from the body? I mean, the problem with problem and like a challenge of senescent cells is that they are not one thing. That, like, for example, depending on what part of the cell cycle the cell goes into senescence will determine its behavior. So you have different stem cells acting differently. Did I say stem cells? I meant senescent cells. You also don't have really perfectly clear biomarkers. So that's a challenge as well. Like, we do tend to see that there are an increasing level of something called P16 Inc4A. This is basically considered like a marker of senescence. Not all cells express that are senescent, and those levels can rise independent of being senescent. But there is something called a senescence clock in T cells, your immune cells, T cells. And that basically this P16 mRNA roughly doubles every 8 years. And there's also this like basically like a 2.5, 2.4 rate increase by decade. That's how I was kind of talking about this exponentiality. So that's another way to even look at your biological clock, is to look at this biological marker and see where you're at. But all of this stuff is provisional. It's not necessarily made its way through the full validation process where it's being administered. But it kind of brings up a bigger point where the pace of innovation is dramatically outpacing our ability to validate these types of interventions. Validation takes a lot of time, and the innovation is like, I don't even know what the ratio is, but it's probably like 100 to 1. And that leaves us in this world where we hear about all this cool stuff, and yet, like, modern medicine hasn't changed much. I mean, not fast enough. And then you have now these longevity clinics that are doing certain things faster, more aggressively, like the stem cell stuff we've been talking about, like injecting, in Florida. But I think we can do a lot of good, always working on our lifestyle and with smart usage of supplementation. And then just see how you feel. Like, you've had some experience with stem cell?
Yeah, so I used it a couple days now in a row, and just today. I didn't realize taking it in the evening was a better time to do it. I've been doing it on an empty stomach first thing in the morning, a couple hours before I take anything else. And I was telling you a minute ago off air that I took it this morning, and I did a neurofeedback session about 2 hours later. And for whatever reason, I was a bit sleep deprived, but 2 days in a row now, my neurofeedback sessions have been the very best they have ever been. I've gotten the highest scores both days, and I don't understand why that would be from a stem cell improving product, but that was a shocking observation. And then also, I've definitely felt more energetic today, a bit of like a nootropic effect, even though there's, as far as I can tell, not really any stimulating substances in it, aside from perhaps like Panax, nodo ginseng, and I think that's about all.
Yeah. I'm trying to think if there's anything else that's stimulating in there. I think you nailed it. I think the Panax nodo ginseng has some stimulation effects. It can. Like, I'll take it before.
It's not like a really strong like energizer like caffeine or paraxanthine or any of the other like metabolites and crazy nootropics you can find out there. But I wasn't expecting to have any impact on my energy levels, and with this, it's been a bit smoother.
Yeah, I'll be curious to see if you take it at night, if what you notice next day effects. I don't doubt that because with several of the ingredients that are in the formulation, like I said, you will see an increase in stem cells within an hour. So that's one of the goals, is to drive proliferation, but not just that, right? We're not just trying to make more. We're trying to make sure that they find a home and become functional tissue. But yeah, with, notoginseng is not used for any sort of stimulation effect, but I will take a form of ginsenosides prior to exercise, and I don't feel caffeinated. I feel robust. Like I just feel like a little stronger and more virulent somehow, but it's a part of my own personal supplement stack prior to pre-exercise. But yeah, try it at night. I should mention this. The product was not tested in that way. It just makes sense to me. So if you take it and for whatever reason you prefer to take it in the morning, don't let the time of day stand in the way, because all of our usage has been really tested around just probably closer to what you described. We told people in our study, just take it at the same time every day. But because of how, I understand stem cells to work, I want to try to facilitate, I want to augment the process while it's occurring. And it does have some predominance at night while you're sleeping.
Dan, will you explain that you actually run research on your final formulations? Because that's one big differentiator and one thing that I like about Qualia. And when I was browsing your website, I always check the website after I experience the product myself, so I don't get placeboed or noceboed into having certain effects. But I saw that you guys even publish, unlike most supplement manufacturers, the people who leave less than 5-star ratings on your website, a lot of times it's like, oh, wow, this product has 5,000 5-star reviews and 0 4-star, 0 3-star, et cetera, et cetera. But you guys actually publish the 4-star reviews as well, which is a sign of credibility in my eyes. And a lot of people did mention energy from this product, which I found surprising.
Yeah. I think that, we've heard people report like the very first. So that's something that I'm very proud of with our company, is that we use science to try to identify an area of need. We use science in researching the ingredients to create ultimately a formulation. Our specific method is to try to support the system. So we're not trying to override the system by bullying it with one high dose ingredient. Overall, we're trying to support the natural wisdom, if you will, of the body to help it do its job. And I do appreciate that. And I also know that there is like this idea of the entourage effect, where you can even use lower ingredients when you're using multiple ones that have like kind of similar targeted pathways. We're seeing that in the pharmaceutical space. Like, for example, the next generation of obesity targeting drugs, they're using multiple different pathways to get results that are now close to double what the original formulas were when it was just one target, right? GLP-1. Now it's GLP-1 and GIP and some other compounds as well. And they're creating really great results. We've been doing this for a long time. It's part of our method, is how do we support that whole system? The other thing I'm really proud of is that once we complete the art of formulation, because it is an art, right? You're doing your best to infer the right value from this broad database of ingredients, some of which are in humans, some of them which are preclinical, but they have interesting effects. And we put those together, and then we put it to the test. And so if you look at NAD, we start with lower quality research. Quality typically means you have less confidence that those results are real when you show them. It doesn't mean it's conducted poorly. It doesn't mean it was designed poorly. It just means that it doesn't have all of the controls that offer greater confidence. But that's where we start. We start with a survey. What do people say? And we learn. We have people that be like, oh, I had this, my joints felt better right away. I felt more energy. We have other people who are like, oh, I felt a little bit more achy the next day, and it's hard to know what's real in that until you start to see some statistical significance within these trends. Then the next thing we typically will do is maybe a single blind study where we are not blinded as the researchers, but we will give it, and it's, a pilot trial, 10 people, there's some degree of controls. And then we'll go to a double blind placebo control trial. And here we're looking typically to see two different things. Is there some sort of biological marker that is affected in a way? Like, do we see, for example, with NAD, do we see levels of NAD increase in red blood cells, right? Then we'll also ask, how do you feel? Do you feel more energized? We'll run some questionnaires around vitality and aging, and do you actually feel better? And what do you report? And then we'll look for statistical significance across all of those. And we publish everything. We publish good or bad. We put it out there. The other thing that we do is we don't stop at one product. So if you look at our Mind product, we're on the third version of it, and we're already working on new versions of new products. It doesn't mean they're broken. It just means, as the research continues to accumulate, we're constantly on the search, on the hunt for how to make it better. So it's almost like a software product, right? Like it's like a SaaS product. You might be taking Senolytic 2.0 in a year, right? Or a year or two. And we're proud of that. It doesn't mean this one's broken. It just means if there is a way to do it better, we will pursue that.
All right, Dan, you have a hard stop in a minute, so I want to be respectful of your time. Rapid fire. How quickly do you expect people would start to notice effects from this product? Like, would it be a week or a year? And then also, are there any side effects or people that should not take a stem cell health enhancer?
So the platitude of talk to your doctor before you do anything, even get out of bed in the morning, is one that usually is for legal protection. I actually support that idea. If you have any sort of condition, medication, go to your doctor, tell them what you're doing. And, for example, you might be on a drug that has an impact on your cytochrome system in your liver, which would mean that the exposure to some sort of nutraceutical that you're taking would be higher because the enzyme that helps metabolize it is suppressed or amplified. That's why it is smart and to go talk to your doctor. So I do support that. And it's hard to say there are these populations that shouldn't do it. So go, because I can't process all the different conditions and all the different medications, but your doctor will know you and what you're dealing with. So talk to them first. That's the answer to that question. And then what was the first one?
How quickly do people expect to see results from using this?
I think a good window is going to be 3 months and I have the saying, the meaningful but invisible, where you are having a real effect, but it's invisible to you because it's taken some time for the effect to occur. So let's say theoretically you had a 25% improvement in joint stiffness, right? Or kind of like just how loose and mobile you feel, which is a sign of just getting older. Well, because it took a little while for you to feel it, it wasn't immediate, like an anti-inflammatory that you take and then you feel better like within a few hours or the next day. You acclimate to that feeling, even though it's real. And you would, if you had objective data to show you where you started, where you arrived at, you'd be like, oh yeah, definitely. It's just part of the disadvantage of anything that doesn't act immediately. Okay.
Yeah. So take notes. Once you have your notes, then you can compare the before and after.
Exactly. And then the other part of that model is that, you can have the meaningful but invisible in both directions, the positive effect, but also the negative effect. But you're like, if something is in your life causing a decrement, but the decrement is an advantage, because what calls for our attention is the problem, the stiff and achy joint that gets achier over time. When something heals, you're just noticing it less. There's less drawing your attention to that area, right? It goes back to the place of like, oh, there's other things that are capturing my attention. So yeah, like you recommended, if you have some aches and stiffness, maybe do a visual analog scale where you say, okay, here's a 0, here's a 10. Where do I rate it? You could just do one on a piece of scratch paper yourself and say, okay, I'm going to do, my knee, my ankle, my back as some orthopedic ideas. And then where do I think I grade myself on average? Not just today, but like average, where am I on these areas? And then put a calendar reminder for 1 month, 2 month, 3, or just 3, and then do it again and see if there's any changes and improvements. that might help you stay on something that's having a real effect, that you would want to continue digging.
Awesome. Well, Dan, thank you so much for joining me. If you guys want to check this out, this is the Qualia stem cell product. You can use the code URBAN. I believe that'll save you 15% on your first order, and give it 3 months and then check in to see how it is before and after. Dan, appreciate your time, and thank you all for tuning in and sharing your energy and attention with us today.
Yeah. Thanks for having me on, Nick. Always enjoy and appreciate the opportunity to speak with you.
Likewise. Until next time, be an outlier.
Thanks for tuning in to High Performance Longevity. If you got value today, the best way to support the show is to leave a review or share it with someone who's ready to upgrade their health span. You can find all the episodes, show notes, and resources mentioned at outlier.com. Until next time, stay energized, stay bioharmonized, and be an outlier.